this video, we're going to look at solving right triangles. So if you recall, we looked at SOHCAHTOA previously, and SOHCAHTOA can be used to help us to find our trig ratios. Now, in this instance, it's going to be important for us to highlight our corresponding sides. So if you recall, sine was equal to, or if you had, let's say, sine of alpha, let's be a little bit more specific. Sine of alpha is equal to opposite over hypotenuse, right? And then cosine of alpha is going to be adjacent over hypotenuse. And then the last one we looked at was tan. And so tan of alpha is going to be opposite over adjacent. Now, when we're told to solve a right triangle or to find these trig ratios, this is what we're going to need to know. Okay? Now, here we have our alpha. And so recall that alpha is what's going to determine our opposite side and our adjacent side. So since alpha is here, the side that's directly opposite, right? Or facing alpha, that's going to be your opposite side. And then the side that is adjacent, or like we like to say, beside alpha, that's going to be your adjacent side. And of course, we know that the longest side is our hypotenuse. So now once you've highlighted or noted all of your different sides, you can just plug in for your ratio. So sine of alpha, that's going to be your opposite. So in this case, opposite side is measure 8, and our hypotenuse is 17. So this means that sine of alpha is 8 over 17. Now, if we want to do the ratio for cosine, now again, cosine is adjacent over hypotenuse. My adjacent side is 15, so that's going to be 15 over 17. Now, lastly, my tan ratio is going to be what? That's going to be my opposite side, which is 8, over my adjacent, which is 15. So if I were to write this all explicitly, this means that tan of alpha is 8 over 15, and cosine of alpha is going to be 15 over 17. And so this is how you would solve to find the ratio of sine, cosine, and tan for your right triangle. Now let's look at another example. So here, of course, what we want to notice is that your sides vary based on where your angle is. So previously, our triangle did have a different shape, right? Our triangle had a different shape. And because of that, our alpha was in a different location. But the same thing applies. First, let's highlight what is my opposite. Here's my opposite side. This is going to be opposite. And then we have our adjacent, right? Which is right beside of my angle. In this case, T. It's going to be my adjacent side. And then, of course, the longest side is my hypotenuse. So if I want to find, let's say, sine of T. So sine of T is going to be equal to what? Recall, sine is opposite. I'll write it over hypotenuse. So this means sine of T is going to be my opposite side, right? That's facing T. So that's going to be 7 over my hypotenuse, which is 25. Let's say I want to find cosine of T. Well, cosine is adjacent over hypotenuse. And here my adjacent is the side that is right beside my T. So that's going to be 24 over my hypotenuse, which is 25. And lastly, tan of t. Well, that's going to be what? Tan is opposite over adjacent. So that's going to be what? My opposite side, which is 7, over my adjacent side, which is 24. And that would be my ratios. Okay? Now, we may get a triangle, and we are asked to find missing angles along with the missing sides. How do we approach these? Well, first with something like this, let me plug in what we have first. We know what C is. We were given that C is 15. We were also given that A is 8. So we can actually plug in those values. Now, I'm looking here, and I think the easiest thing for me to find first, right? We're going to find everything that we need to. But it would be, if I were to look at it, I think B. Because I know that angles in a triangle sum to what? 180 degrees. And so, yes, if you said it, you got it right. So now let's see. I want to find B. So this means for us, right? This means that what? It means A plus B plus, recall, this is going to be 90 degrees, right? So plus 90 should sum together to give us 180 degrees. But we know that they gave us A, so I can plug that in. So 8 plus B plus 90 is equal to 180. In other words, if I were to add these together, I get that what? B plus 98 is equal to what? 180. So now if I wanted to find, well, what is B? Well, I will subtract 98 from both sides. That goes away here. So we have B is equal to 82. So I can actually plug that in on my triangle. So this is going to be 82. Now what this does for us is, I'm going to also write it here. It's going to be 82. Now this gives us now more flexibility of how we can solve for the missing sides. Now recall, we talked about the different ratios. We can pick an angle, and then based on the angle that we select, or sides will figure out which is adjacent, which is opposite, and so forth. So for instance, let's say I pick angle A first, right? So for me, angle A, the opposite side for angle A, and I'm going to use a color, a beautiful color here to represent A. So the angle here, this one is going to be my opposite side for angle A, right? And then this side B is going to be what? My adjacent for angle A. But some of us may say, I want to use angle B. Well, we can. Well, but what's going to change is our opposite and our adjacent side. So now, if I'm using angle B, B becomes what? The opposite. The opposite side for angle B. And then A becomes the what? Adjacent. Very good. For angle B. Now, depending on which one you choose, you would use the respective sides to get your ratios. Okay? Now, let's say I want to find side A. So I'm going to look for side A, and I want to use angle A. So now when you're doing a question like this, it's going to be important for you to note what information do you have. So for instance, we have C, the side that we have, it's C. And I'm looking for side A. So I need a ratio that in respect to my angle A has the hypotenuse, which is 15, and the opposite side. Why am I saying this? Well, because if I were to say, oh, get a ratio that has my adjacent and my opposite, then those two are unknowns and I would not know how to solve for either of those sides. So I'm going to use a side that I know. For instance, I know C. So I'm going to use my hypotenuse, and for my side or my angle A, I'm looking for small letter a. So that means I'm going to be looking for my opposite side. So the ratio that has opposite and hypotenuse is sine. So I'm going to use sine of angle A. And so that's going to be equal to what? Well, we just said it, right? Opposite over hypotenuse. Okay? Well, we know what A is, so I can plug that in. So sine of 8 is equal to, opposite side for me is A. I don't know what A is. And my hypotenuse is 15. So this is what I have here. So now I want to find, well, what is A? Now, if I want to find A, I have to multiply both sides by 15 because I need to get rid of this 15 here. So I'm going to multiply both sides by 15. So in other words, what I'll have here is 15 times sine of 8. And I'm going to put this in parentheses just so we know how to plug this in our calculator. Okay? And that's going to give us A. Now, you should be able to find sine on your calculator. So you can literally put, if you're typing it in, it's going to be 15 times. You have your multiplication sign. And you'll just type sine, and you should see a sign on your calculator, 8. Okay? And when you do this, you should get 2.087. But if you were to round up, it would be 2.088. Okay. Now, we can just say 2.09 since it's 8 here. We'll just use 2 decimal places. So we'll just say 2.09 since there was an 8 beside it. Okay. Now that's A, so I can plug that in. I can put that into what I was looking for. So we found A, which was 2.09. Now we need to find B. So there are 2 ways that you can find B. You can find B using the trig ratios, or we can use our good old Pythagorean identity, or Pythagorean theorem. Sorry, I'm thinking about trigonometry. All right, so now let's say we want to use our trig ratio. I'll do both. So if we want to use our trig ratio, again, like we did before, well, now we know A is 2.09. So we actually can use any trig ratio at this point because we do have 2 sides. And so we're only missing one side, so we can really plug in any of them. We can plug in any hypotenuse, the opposite, or adjacent. I'm still going to use my angle A. Okay, so let's use cosine. Let's use something different. So cosine of angle A, if you recall, that's going to be adjacent over hypotenuse. Okay? Now, if we're going to do that, we're going to look at our A. My adjacent side for A, that's going to be B. My hypotenuse is what? 15. And so I have cosine, and we know what A is. A is 8. So again, I can just literally plug this into my calculator. But first, I will need to isolate B. I need to get B by itself, right? And to do that, we're going to multiply, okay? Multiply, like we did before, both sides by 15. And so this should give us, well, B, right? Because 15, so we'll have B is equal to, oh, let me go down a little bit. There we go. So B is going to be equal to 14. We'll just say 85. Okay, 14.85. So I'll plug that in here. 14. There we go. 0.85. Now, let's say you wanted to use the Pythagorean theorem. Let's say we want to use the Pythagorean theorem. Do we remember what that is? Let's see. Okay, so this means that what? A squared plus B squared should be equal to C squared, right? So let's plug in. Again, this is if we were solving for B. We know that A, or we found that A was 2.09. So we can plug that in there, 2.09 squared plus we don't know B. So this is if you were to use the Pythagorean theorem to find B. We also know what C is. And I would like to note here, you can only use Pythagorean theorem if you know two sides, right? You can't use it if you have two unknowns. Okay. So yes, A squared plus B squared is equal to C squared. Okay. Now we can simplify this, right? So 2.09 squared would be 4.37 or 3681. And so I'll just run it out to 37 plus B squared is equal to 225, right? 225 is 15 squared. Now, I'm trying to get B by itself. So first I'm going to subtract 4.37 from both sides so I can isolate, right? I want to isolate that B squared. And so if I subtract 4.37, I'll have that B squared is equal to 220.63. But I am not done, right? I need to figure out what B is because that's essentially what we are solving for. And so if I want to find what B is, I have to take the square root, right? I have to take the square root of both sides to get B because square root will cancel the square, if you may. So this means that B, and you can plug this in your calculator as well, it's going to be 14.85. Well, 853, but if we were to keep it to two decimal places, it would be 0.85. And know this is what we got when we use our ratio. So whichever way you chose, you should have gotten the correct answer.